Hello, everyone. Good morning, good afternoon, or good evening from whichever part of the world you may be joining us. Welcome to this week Community Tech Talk. Let's get things started. For those of you who may be new, which I indeed see some familiar faces, so it's good to have people joining back and tuning in into these sessions. But if you're new to these community sessions, all of these is just for you to keep, for us Googlers, to keep enabling you on Apigee in application integration, all things API and all things integration from Google Cloud. So you'll find these community sessions at your disposition anytime on demand. We will share the recording, and we hope you keep on joining us in these community sessions as we have more things planning ahead. So with that, I'm gonna give you some simple rules while the rest of you join the session. These community tech talks will be presented by a Google expert. In this case, we have Tyler once again with us. At the end, we're gonna have a Q&A, and you can discuss your points, bring your ideas, and ask some questions to the speakers or pivot ideas with the peers around here in the session. We're gonna be meeting almost every Thursday as time allows, with some exceptions by holidays. And like I said, this session is going to be recorded, so rest assured you'll be able to find the recording either in our YouTube channel for the Modern API community or through the community, which I'll make sure I'll ping the link here in the chat for you. And if you'd like to join us in this scenario to share your knowledge with the community, we'll be more than happy to have you. Just reach out to us through the community or through LinkedIn, and we can accommodate you. With that, Tyler, do you want to have questions throughout the session or at the very end?
Either way is great. During the session is great. If people have questions, just ask.
Great. Thank you, Tyler. So yeah, feel free to raise your hand, share your question on the chat, and we can give you a space for you to open your mic and pop your question. Alrighty. As you know, some of you are familiar with Tyler, which is a really frequent speaker in these sessions with us. Tyler is a principal architect for Apigee, and he works for the Business Application Platform Unit here at Google Cloud. And today's topic, he will be presenting us cloud-native services and APIs with Google Cloud Run and Apigee. So welcome, everyone, and take it over, Tyler.
Okay, great. Yep, thanks, Alex. And hello, everyone. Welcome to this session. Let me share my screen, and we can get started. So I'm sure many of you are Cloud Run users, Cloud Run developers, the operators in this team. It's one of the most popular services on Google Cloud. It's just the go-to container, app running service. We use it for all kinds of things, right? For demos, for POCs, for anytime we need to spin up containers. Cloud Run is just one of those amazing, just an amazing service, right, within the GCP service portfolio. Often we talk about cloud native apps and how we can, reduce infrastructure, make it, be more agile, have a faster time to market for new services, new developments, right? And when we are talking about cloud native, we're often talking about microservices, sometimes with containers, sometimes without. DevOps, SRE, and of course APIs, right? So how can we bring all of these things together into architectures that we can, very quickly and with minimum effort and delay bring to our users? Sometimes we say that, for cloud native, there's like two paths, right? You can focus more on business logic, and then you would use more serverless options, or you need more control and flexibility, and so Kubernetes and a full container orchestrator is necessary for that, right? In Google Cloud, of course, we cover both options, right? So Kubernetes is always there, GKE, also in, you can run it anywhere, also on premise. And then, of course, for serverless, now Cloud Run is the go-to service. Cloud Run includes Cloud Functions, so you can run functions without any containers, but of course, you can deploy any type of app in containers and also multi-container apps within Cloud Run. What is serverless? So Cloud Run is serverless. You have no infrastructure, management effort or responsibilities. The operational model, no server management needed, fully managed security. You pay only for usage. And from the programming perspective, it is service-based, it's event-driven, and it's very open and agile to deliver services and push out updates. Just to give an overview of how this fits together: Kubernetes engine, Cloud Run, of course, GCE compute engine, for any VM needs, and then of course fitting into the larger service portfolio in GCP. Some of the benefits of Cloud Run, just to put a measurement, to put some numbers on it, is just the velocity and the productivity. It's also been proven to be extremely reliable. Also, in case there are networking or other issues or services are unstable, the reliability is just one of the best in class for these types of platforms. Also, especially for spiky workloads, there is a lower cost. So this has been measured to be 95% faster than using other types of legacy platforms, more stable, 98% fewer interruptions to services, and then also cheaper than provision platforms and much cheaper than on-prem, just because it really is on-demand, an on-demand service, and also with scale to zero, right? So if containers are not being used, they can, if you want, fully scale to zero and not cost anything. Some of the triggers in Cloud Run are, of course, HTTP. Basically, any type of HTTP service, from HTTP2 to WebSockets to gRPC to REST, now to MCP to streaming, everything runs through HTTP and Cloud Run. We can connect that with PubSub for eventing, cloud storage, of course, to access files, to have persistence using the Fuse storage driver, which basically gives unlimited storage access to Cloud Run containers. And then, of course, we can connect into Event Arc to get events from any type of GCP service. So anything, an event, anytime an event happens, we can trigger a Cloud Run service. Of course, we can also do this on a schedule or part of a workflow via Cloud Scheduler, workflows, or, of course, application integration can also trigger Cloud Run. So the example I want to bring today is kind of this, looking at how to deploy some of the more modern workloads on Cloud Run. Now we can actually deploy models as well on Cloud Run with GPU access. But regardless of what type of service it is, right, we can deploy our Cloud Run service, connect it to any backend services we need, like Vertex, SQL services, AlloyDB, and then put Apigee in front of it for API management. Now that means that Cloud Run can also be an internal load balancer, and Apigee is handling all of the user authentication, authorization, routing, quotas, all of that traffic and security, all of the public exposure topics and orchestration topics Apigee can handle quite nicely. And Cloud Run focuses on just service providing the service and scaling the service that is driving the app. This can also work for internal workloads. So Cloud Run can be put, you can turn off public access. You can put it within your own network perimeter. This can be either shared VPC or available through PSC. And this is also a way to offer selective access to users through Apigee, right? So Apigee can be the public endpoint or also internal endpoint, but where users go to, where services are discovered, APIs are published, and then through Apigee connecting either through PSC or the shared VPC or VPC peering to the Cloud Run service through an internal load balancer. This is quite cool because this is, offers, managed secure gateway through Apigee to internal workloads, so you don't have to open up your Cloud Run services to the internet, to the public world, and then putting a managed access path in place for authorized users. Of course, some of the most popular features of Cloud Run is the pay-per-use model. So really with easy pricing, committed use discounts, right? So you really only pay for 100 millisecond blocks of what you use. CPU and memory scales on demand, and you can configure exactly how much resources are consumed. And then thinking, about use cases with models and agents, this is like an ideal runtime for AI agents, right? We can offer the APIs in Apigee, run the cloud services that could be based on using LangGraph or Agent Development Kit in Cloud Run. Those are, of course, running agent workflows and communication to different databases or backend models or database access, and of course connecting to tools and MCP as well. Here, this can be, of course, through the API layer, which we recommend. So having that consistent authorization authentication in place, also for MCP services. But of course, you can connect to those if those are internal directly from your agent development kit as well. Often, I think if we want to offer those MCP services to external users, which I think is becoming more and more of a thing, right? Then that would go through the API layer. And the same for A2A as a service, right? So this is something I was looking at earlier this week, is that once you have an agent published with ADK, you can publish that as an A2A API, right? Just with one command, right? You can make that an A2A endpoint, publish it through Apigee, and your agent is now an API that can be discovered and consumed, by other agents theoretically as well, right? Cloud Run has got a ton of positive press out there. So if you go to the LangChain GitHub, Cloud Run is showcased as the easiest and fastest way to get LangChain app running in production. For me, with Agent Development Kit, it's the same, right? So if I do any Agent Development Kit agents, Cloud Run is the go-to way to publish those. Those are Python services, just one command to deploy them and have them scaled in Cloud Run. And it fits really the agentic use cases perfectly, right? Because it's just really automatic, on-demand, rapid scaling, very cost-effective, no infra management. So basically, at the speed of how we're developing agents, testing new use cases, Cloud Run just fits perfectly into that picture. Of course, the flexibility, of course, also is key, that any agent framework can work, right? From Python, JavaScript, anything else that might be needed. I just recently saw as well that ADK is coming to more platforms as well in the future, which will be really cool. Today it's Python and Java, but there will be other languages supported in the future, which I thought was really, really cool, right? So that means that we're just getting more flexibility for agent development. Of course, Python is kind of, the go-to language these days for Gen AI and agent development. But I think a lot of developers out there are, me included, are very happy to have other options there available as well. For example, JavaScript and Go. And again, the flexibility of the protocols that are supported, right, with HTTPS, endpoint, streaming, HTTP2, WebSockets, SSE, MCP, and all of this can be proxied easily without any additional effort through Apigee as well. With more and more MCP servers, I think Cloud Run is also a really nice use case for that. Just if you need any MCP services deployed using the SDKs from MCP, then this is how I'm doing it as well, just deploying them to Cloud Run and then connecting them into the agents either through APIs or directly. And a pretty new development this year in June is Cloud Run with GPUs is now GA. So now also for inference or training tasks, you can also use Cloud Run very easily. This is really simple. So if you want to run a model from Hugging Face or run it yourself with a GPU or with multiple GPUs, this is really easy to do just with the gcloud commands and then connecting GPUs to the containers, and it just works. Still also with scale to 0, which is pretty cool, right? So that means you really only pay for the milliseconds that you use, and you don't have to block a GPU by attaching it over a longer time frame that you might not need. So it's really just deploying and running our own model, any open models, fine-tuned versions of models on demand really, really nicely with Cloud Run. It really is just a matter of seconds. So in the demo in a moment, we're going to deploy a container with a model connected to a GPU for inference. Literally within seconds, we have it up and running, and we can use it as a service and as an API. The measurements for cold starts and time to first token have come down a lot. So there's lots of ways to optimize this as well. This is for any type of service in Cloud Run. You can optimize the cold starts. You can also allocate more CPU to make sure that the container starts as quickly as possible. You can also do async initialization of code to make sure that you can start receiving traffic as fast as possible, right? And we can get, even for relatively large models, you can scale to 0 and minimize the cold start time really nicely. Some of the ways of optimizing that, as mentioned, optimization of driver installation, so things don't have to be initialized immediately every time. Streams the images. Images are super fast to start up because the images from their Docker and artifact registries can be streamed really fast to get them into memory. Of course, pre-provisioned GPUs are available in regions. Either you can have them, within an availability zone or within the whole region. And then, of course, micro VM technology, so GPU VM deployments. So let's get to a demo now to go into this in more detail. I think, let's just jump over to the demo. So here's the announcement from June that Cloud Run now supports GPUs. So this is relatively recent from this summer, but it's now GA. So you can really use this in production with all the features we just mentioned, right? So it's really ideal for model usage behind APIs. In this demo, we're going to run Gemma 3 on Cloud Run. The command to do this is super simple. It's literally just this here. So one gcloud command referencing a public container, setting the CPU memory, 1 GPU, NVIDIA L4, 32 gigs of memory, and no unauthenticated access, so private only. And then we can use Apigee to offer this as an API to users. So let's go ahead and take a look at this in action. Let me just jump over to the Cloud Run deployment. So this is deployed in my project here under Gemma 3 service as a container, just with that one command. If we dive into the metrics, we can see that in real time, we can see the metrics, let's say from the last 6 hours, how many requests are coming through, what are the average latencies, how many instances of the container, right? So we limited it just to 1 instance. So it's just going to take 1 instance, 4 requests at a time. So it's also going to reject requests after that. We could scale up, of course, if wanted, but just to optimize tests or different, during testing or POCs, then we can also put that in, constraints to save costs. We see exactly the billable container instance time. So we're only paying for the CPU and GPU when the container is in use. We're not paying anything for when there's no traffic to the container. And then we also see that the memory utilization is only, around 3%. So that means the 32 gigs of memory are perhaps too much, right? That was from the tutorial recommended, but maybe we don't need that much memory as well. So something we can keep an eye on. And the startup latency, as mentioned, is, this is just the 1 billion Gemma containers. So it's the smallest one, but, we can get below 5 seconds, which is great. And, have fast startup times. And we also see the GPU utilization. This is just for inference, right? So this is just a service user prompt requests is also quite low. Great. So here's where our service is running at this URL. It does not allow unauthenticated access. So if we switch over to a terminal and let's do some commands with the service. So for example, so the service has been deployed. Let's get the service URL just using a gcloud command and save it in a variable. Oops, that's the wrong service. We called it Gemma 3 service. So that's our service URL. if we try to call that, it's not going to work because we need to authenticate to access that. We have no unauthenticated access is allowed. So if we just do a request to that endpoint with just to the /API/generate with a question, we get a 401, so unauthorized, right? So that's good. So it's privately deployed. We could put it further behind an internal load balancer and limit all public access. But in this case, we're just going to use the authentication as security to say, no, we have to go through an API to access this service. So the next step is to deploy an Apigee proxy that proxies to our Cloud Run service. So I have a GIMA 3 v1 proxy deployed. It is just proxying traffic to our Cloud Run service. And it also is deployed with a service account so that we can use that service account to access the service, right? So if we do a debug session and take a look at the traffic to the API, we'll see that it's using a service account to access the Cloud Run endpoint. So let's go back to our terminal and first of all, get our Apigee host from my project. You can also do this with an Apigee CLI command. So to list the environment groups, and then just take the first.
Tyler, we are still seeing your.
Oh, okay. Thanks. Yeah. Let me switch over. Yeah. So let's get our Apigee host and go use Apigee CLI to go through our environment groups, list them out. I just tried it and it said we need a token. There's also a really nice feature in Apigee CLI. We can just say default token. If you have a service account or default application credentials configured in your gCloud, you can just use default tokens with Apigee CLI. And we have an Apigee host. Is an NIPIO. I am going to save that in another variable name, so Apigee _host. And so now let's make a call to our Apigee endpoint. Or actually, let's first call our Cloud Run endpoint with a token so that we can see the raw results. So we tried to call it here without a token. We get a 401. Let's call it now with a print identity token from gCloud. So Cloud Run needs an identity token for authentication. So we're just going to send that from my local gCloud account just to test it out. So the container is stopped because it hasn't had any traffic for a while. So we're going to say it's going to take a little, like 5 seconds, and then we start getting the results from the GIMA model. You also notice this is using the OpenLlama, the OLlama way of hosting the container. So we're not getting a nice API traffic here. We're getting pretty raw, basically individual words and token responses to that question, right? So that's not very nice, not very pretty for users, right? So this is kind of very raw output. So let's now try the Apigee endpoint. So we have our Apigee host. Let's just call it. So now we're going to call our Apigee host /GIMA3 generate with our question, why is the sky blue? And so now it's sent. And then we see, oh, now we get a nice API response to that, right? So our API endpoint can also consolidate and orchestrate some of that raw data. And for example, use the OpenAI interface to return that in a message content format, right? So the API is useful for a variety of things, right? So it can connect to our private Cloud Run service. We can also do some consolidation of the response data, transform from some raw data that's being streamed here into an API response for users. An additional thing is, let's do that again. JSON PP installed, let's see. Yeah, if we get that formatted, then yeah, we can get the whole message and content put into a JSON response, and also do some token counting as well, right? So here at the top, the raw data, we don't have any of those nice token counts. We just have kind of some evaluation duration, the prompt count, but very raw data regarding the results that were returned. So we can consolidate that down and return the actual usage tokens to the users, right? So with this, we've taken just that raw container, put an API in front of it, and this is something we could also, of course, document in an open API spec, right? To say, hey, we're using the the OpenAI, the Open API format for model prompting, and we're fulfilling this API contract. And it's much easier, of course, to publish that documentation to users than as the raw data. Let's take a look at our Apigee traces to see what the communication looked like. So the first request, basically came in with our request here. So why is the sky blue? We have no policies in the pre-flow. We go to the target. We see that, okay, that's when we got all of that raw data back. And it's not being streamed. At least this interface is just providing that as about a lot of text, right? It's just text data. The individual messages are sometimes JSON, sometimes not. But that's basically the body. And then a JavaScript policy to split that into lines, test if it's JSON, and consolidate the content then into the response. So we see that, okay, when our JavaScript policy is executed, it sets the body then with the choices message content format to return a structured response to the user. Let's see how much time. So it's 6 milliseconds for that consolidation. Since that's quite a lot of data and content and string processing that was needed for that, I think that's pretty good. The JavaScript policy in Apigee is very optimized. That code is compiled down to bytecode and run in the JVM, in the Apigee runtime proxy. So it's pretty optimized execution then to do this type of processing. If we look down then at the end result, we can return structured data to the users. Good. I think the next step, what I would do in this proxy is change the request to also be the prompt request using the Open API format for model prompting. So removing the model inputs and just letting the user prompt, and then putting that behind an Open API specification that can be properly documented and published to a portal. Good. Any questions on that example? So basically, our proxy, putting some structure in front of the Cloud Run model back in service, Cloud Run using GPUs, as much memory CPUs as needed, right, to perform the operations in the background, and then basically putting the interface, the front end on it for users then through the API layer. Of course, we could add here in the pre-flow any authentication and authorization that we want, right, from OAuth to API keys or anything else, to make this more open and consumable by the right, our right types of users that we're targeting, right, if it's internal or external or whatever, and of course manage subscriptions and publishing then within portals. Any questions or comments on the demo?
Can you show us how this JavaScript looks like? Is it all tied
sure.
up to Gamma, or it would be a generic for any kind of model?
Oh, that's a great question. Let's take a look at it. So how I usually approach the JavaScript is, if it's, so this is, a pretty short algorithm. I would also normally put testing in place for the JavaScript as well, right? Just to document, the inputs and outputs and test that accordingly, right? The JavaScript is often, it's just retrieving, the request or content, the response content. In this case, we're getting a lot of text, right? So splitting it up, and then just going through the lines and checking, hey, is this structured JSON model input? If so, parsing it and building our content response that we're going to send back to the user, right? If we find content, then building that response object, doing the token consolidation and counting, and then setting that in a final response object that we're going to set back to the response content, right?
Yeah.
So very straightforward. I think this is one of the really useful features of Apigee, right, is that we can put this logic in here easily. We can test it, we can validate it. For these types of formatting and consolidation tasks, it's really, really useful, right, without having to deploy another container or another service that does that instead. Right?
Thank you, Tyler.
Mm-hmm. Any other questions or comments? I think also it's very important that, especially for, let's say, cloud native or teams that are deploying to Cloud Run, right? So they're used to deploying using Terraform and gCloud, that they can push their API definitions also, just as easily using Apigee CLI, Apigee GoGen potentially for any generation needs for the Apigee proxies. So basically having that automated end-to-end. The console and debugging is very useful when things are finished or deployed, right? But in that initial setup phase, I think here, what I would do is the team, put that open API spec in place, generate the proxy based on that, and use that for the deployment, right? After generating the proxy, we can inject the JavaScript, inject validated policies right into that. And that can all be done completely automated in our build pipeline. And I think that's pretty common, is that a lot of, Apigee customers, they don't, typically, or at least for a lot of teams, don't have or don't want access to the console for any deployments, or at the most just for debugging or just for, metrics and analytics and those types of tasks, right? But not for proxy development. So that's something we can standardize completely in an automated way. And that makes it really accessible and useful for, let's say, cloud native teams, right? So they can push their API definitions in the exact same pipeline as their service deployments, right?
Thank you, Tyler. I guess someone raised their hand. It was Purna. So you want to open your mic and share your question?
Yeah, hi Taylor. So, I have a question, like, can we have a prompt to query data from the BigQuery in a more reported manner if we use a connection from Cloud Run to the BigQuery directly?
Yeah, that's possible. And thank you, Prerna, for the question. Can we? So I see your question in the chat as well, right? So can we use a prompt to retrieve? Yes. So this is something we can also read. So BigQuery offers an API. There's actually a GitHub repository that I use for these types of mapping tasks. Let me find that real quick. And we can add this to the notes. I think Apigee modules, JS modules, exactly right. So this repository is just kind of where I maintain different conversion modules, for example, from BigQuery or Firestore or Gemini. And this is often when, if I look into my tests here, I have all of my sample data. Like, for example, I had a customer use case with BigQuery with Fire data, which is like healthcare data. Very complex data models, right? With lots of hierarchies of data, right? Which BigQuery completely supports, which is great, right? But this is also not nice to return as an API, right? So basically, the BigQuery methods here under source then are the JavaScript files that you can easily integrate into, so BigQuery functions or any of these you can easily put into proxies. So this is common JS, so you can use it in proxies without issue, and just offers the functions like generate query, convert response, to basically convert those big payloads, complex payloads into nice JSON or nice response formats that we want to send back, right? And the cool thing is that this JavaScript functions can be nicely unit tested with vtest or Mocha, right? And then just having all of that data here. So, for a fire simple, it looks like this, not quite as big, but just a test, have tests in place for that, or for data protection responses, whatever type of data we might be getting back, developing that with testing here, and then these functions we can include in Apigee proxies and just utilize without having to type them into the Apigee console, right? Yeah. One little part of that, so for BigQuery, that's great. So the BigQuery API can just deliver the data in the BigQuery API format. It's not RESTful, it's not nice, right? But the JavaScript algorithm can convert that into a RESTful resource response. And there's just one thing to take into account is in the JavaScript, basically you can include, find it. Exactly, something like this at the end. And basically, this will just export it if it's in Node.js. So this you can use for testing quite nicely. But in Apigee, we don't have exports. It's not Node.js, right? It's just a raw JavaScript runtime. So then it doesn't export it. So this little if statement can mean that this function can be used in Node.js testing as well as in Apigee without problems. Right?
Got it. Yeah, that's good.
Mm-hmm.
Yep.
Cool. Is there another question?
Yeah,
Yes,
Tyler, I have one more question if
Sure.
I'm the only one. Yeah, can you help us review the target configuration on the proxy, like how the Cloud Run backend would be wired up?
Yeah, absolutely. So target is, just to either my PSC connection or to my Cloud Run URL, right? And then for authorization with the Google ID token, then the audience must be set as well, right? If you use Apigee CLI to generate the proxy based on an OpenAPI spec, you can inject this. You basically it handles Cloud Run use case that you need a Google ID token with the same audience. This is just a Cloud Run requirement, is that you need a token with the same audience as the URL for the service, and Apigee CLI can generate that automatically. But it's quite simple, right? So yeah, you can just.
Yeah, I've never worked with the Cloud Run backend, so I'm curious. The load balancing and all of it looks like it's not applicable here.
Sure. No, you don't have to do. Apigee can also load balance if you like. Then you would configure this as target servers in the Apigee environment configuration. So we could do that as well if we want to distribute data across multiple Cloud Run endpoints and so on, right? We can configure those as target servers. This is also needed for gRPC endpoints. So if you're using gRPC, you need to configure the Cloud Runs here as target servers, and then you can use Apigee load balancing.
So we can
leverage
the traditional way as well. Got it.
Yes.
Thank you.
Great. Any other questions?
Yeah, I have one question.
Yeah, go ahead.
So I'm new to Apigee, and I just wanted to understand, when you set up all these target endpoints, what's the best practice? Is it recommended to use resource files in Apigee to store them, all the credentials, or do we need to use different KVM policies? Which normally, what's the best approach?
Great question. So in this case, we don't have any credentials because here in my Gemma 3 proxy, when I deployed it, we can deploy it with a service account attachment, right? So I can say basically with this service account identity, and that is used then to generate any tokens that are needed for target. So anytime we have a Google Access token or Google ID token, this identity is used. So that's quite nice because we don't have to store any credentials then in that case. Of course, that's only possible for GCP, for Google authorization and authentication. If you need credentials for your own databases or backends or services, then the first option is usually in KVM or in Secret Manager in Google Cloud, right? So we could easily put them here in a key value map. It's encrypted, and you can inject that using Apigee CLI or using the REST API from Apigee. And you can either say that's at a proxy level or an environment level. And then the proxies can retrieve that KVM data at runtime very nicely. Or if you want to, you could use Secret Manager in Google Cloud to retrieve that as well, just using the Google. You could use a service call out in Apigee to call the Secret Manager API, use the service account to authenticate, to retrieve the secret, and then use that as well within your proxy.
And what about resource files, which are set up at the environment?
The only problem with resource files is that you have to redeploy the proxy if you want to change them, right? So I would not normally recommend putting any credentials in resource files. So so I have my JavaScript. Of course, you can also create a property set here. And say, hey, I'm going to put config properties in this file. This is something you can also, quite nicely inject, and just put environment variables, right? So like, config name equals test123. So you can just put them line by line, any variables here, and you can reference these as variables within the policies very easily. So it's really great for configuration data that doesn't change so often because it's static, right?
Yeah.
The nice thing about KVMs is that, first of all, they're encrypted. Second, you can update them anytime without redeploying the proxy, right? So if you want to change this, you have to redeploy the proxy, which is I mean, there's zero downtime with proxy deployments, so there's not gonna be any issues or anything, but it's just an additional step that isn't really needed because you just want to change, a password or a credential, right?
Yeah, that makes sense. Thank you.
Sure. Yeah, that's another question.
Hey, Tyler, I have one question.
Mhm.
If let's take I make a call and get the token, and I wanted to keep that. Let's take the token is valid 1 hour. Further calls, I wanted to use the token instead of making every time one more call. How can we do that?
Yeah, good question. So I assume the token, it's not a Google Access token, or this would be another token from
Maybe a Google token. Let's take a BigQuery token or a Salesforce token. So some token.
Yeah, just some token, right? Exactly. I mean, what you can do is just save it as a variable in, or actually you can write it to a KVM as well. I'm trying to think what would be the best option there. I would probably just save it in a variable. If you add a policy here, you can say create a new policy, extract variables. So you can extract the token basically from the token response. You probably do a service call out to get the token, right? Using the client ID or whatever. Extract that into a variable, and then you can use it in any policy after that you like, right? So
that is a transaction based, but this is going to be a multi-transaction. We are going to
across multiple transactions. Yeah. So as Varun just put in the chat, using caching, right? So just like writing variables, you can also write to the cache, L2 cache, and you can retrieve. You can put a time to live on that.
What policy is that? What policy is that? A caching point of view?
It's the caching policy as well. So you can do populate cache. You can also write to it, from JavaScript, and then look up cache to retrieve any variables.
Is that a global cache or local? Yeah, go ahead.
You can say if it's proxy or environment specific, right? So it and you can say how long it should last as well. So it expires then automatically. You say, hey, this token's only valid for 60 minutes, then it'll be automatically removed after 60 minutes, right? And you can retrieve it, use it from multiple proxies if needed.
Do you have any, just we were in a kind of, if you have any samples around there, it will be great if you can share.
I think you can find samples everywhere. You all have to create a cache key, dynamically look into the lookup cache. If it's not found, make a service call out, then put it in the populate one. And in the next call, you just look for the cache key. So pretty standard Apigee Edge, old school implementation.
No, I mean, if we are using a cache, right, this is across the transaction I'm looking. If next transaction is coming, still that cache is available for that transaction, not a
Yes.
transaction specific.
Yes, you can decide how long it can be used, the key, and it's available then as long as you need it, right? If you go to the Apigee samples GitHub repository, there's quite a lot of caching examples here of various kinds. So, I mean, the LLM semantic caching is a different topic, but there's basic caching here as well. You find it. Yeah, basic caching, right? So here's an example. If you click the open, zoom in a bit. If you click on the open in Cloud Shell, it'll take you right to your Cloud Shell environment with the GitHub repository, and you can go through the example interactively in Cloud Shell as well. Right?
Sure. Can you ping that URL? Thank you.
Sure. Yeah. So the README for each of the samples always has the instructions. And if you open that in Cloud Shell, there's a tutorial walkthrough, right, that helps you, go through the steps, right? But yeah. And typically with the samples, you will deploy a sample proxy, right, that includes the policies and configurations, and then you can test it and, just play around with it, right, and see how you can adapt it for your needs. Great. Any other questions? So just to wrap it up, so we always share the recordings and the decks from these sessions. So if you want to deploy the container in Cloud Run, the instructions are really, really simple and works really well here in the Google Docs site. The next step would be, putting together an open API spec, generating the proxy based on that with Cloud Run as the backend. That here's the documentation to Apigee CLI, can do that in one go, one command. Here's a nice blog article from Joel, one of our colleagues in TSC based in Paris, who put together an article on using Cloud Run with private networking with PSC and using that as a backend in Apigee APIs. And then there was a nice Google forum post on gRPC services in Cloud Run, using those from Apigee APIs as well. So just some useful links to kind of dig deeper into Cloud Run use cases. And if there are additional questions on this, then just reach out. I think Cloud Run I know there's a big roadmap, lots of features coming in 2026. It is, as mentioned, one of the most popular services in Google Cloud. It has kind of defined the serverless industry a lot of ways. I mean, AWS and Azure have also copied it or added something similar in their portfolios, but Cloud Run is just truly very unique. And I think also in some customer projects, it's been so useful because you can have up to 32 gigs of memory in a Cloud Run service, right? So really, even super, lots of data, lots of processing needs. You can handle that in a Cloud Run service really, really easily, just on demand, right? You just pay for those, seconds that you need it for, and you don't have to reserve those resources for a longer period of time. And of course, same for GPUs, right? GPUs are expensive, so it's super effective just to use those for the seconds that you need them to run your model inferencing and not have to block them or pay for them for longer periods of time. Yeah, is there another question? Yes, the recording will be shared as well as the slides as well. Great. So if you have feedback for this session, yeah, I think, Alex, do you have anything, or what's the best way for people to do that? Here in the Meet, right? Here in the Meet, you can
Yeah.
submit your feedback. Yeah.
Yeah, you just look for this option at the top right corner of your Google Meet, or go into the meeting tools and find the option for polls. Over there, you can cast your feedback on simple satisfaction score, a scale of 1 to 5, how much you like the session, how much you enjoy it. And if you'd like to share more detailed feedback, we also have a form where you can also go in there and share upcoming details and topics you would like to see in these sessions, or other things that we can improve so that we keep on giving you best quality community tech talks to you. So thanks everyone for sharing your votes, and it's really appreciated to receive your feedback. All righty. And looking ahead at our next session, as we start to wind down for the end of the year, we will be having Matt Harman and Omi sharing these new formats for you. We will be joining just for 30 minutes as both of them answer live questions from the forum, both for Apigee and application integration. I just pinged the link in the chat so that you can go ahead and reserve your spot for this session. It's within the same series of these community tech talks. Rest assured, if you already signed up for this session, you'll be receiving communications on the specific time and day for this. This is going to be November the 20th, which is next Thursday, and December the 4th. So we look forward to seeing you at these sessions. And if you would like to nominate one of your questions to be answered through these sessions, feel free to ping me through the community, tag me or something so that I can make sure we'll cover and tackle those questions in these sessions. Thank you, Tyler. Can we go to the next one?
One question.
Yeah.
Tyler. Anything session is happening, Apigee, MCP around anything? Do you have any plans? MCP.
MCP, yes, yes, we do for sure. Yes, so there's some announcements coming very soon on new MCP features and services from Google Cloud in general. Those announcements, I think, just came out, and also for Apigee. So when that's announced, we will be having sessions extra on new MCP features. So yeah, keep an eye out for those. Those will be coming as well. Yes.
Awesome. Thank you, Tyler. A regular invitation for you to continue engaging in other spaces apart from these community live sessions. Go and check out the community spaces for Apigee and integration services. Remember, you have at your disposition in there the forums so that you can continue your discussions on these technical aspects. You have a knowledge hub so you can see these curated articles, how-to tutorials, and videos from Googlers, as well as news and updates that we're sharing on the latest release notes, upcoming events. And so yeah, these spaces are at your disposition, and we'd love to interact in there with you. So with that, that's it that I have for wrapping up the session. It's really great always to see you engaging in these discussions. So anything else I would like to add, Tyler? It was a great session.
No, that's it. And we're working on planning sessions for next year. So if you have topics you would like to see in coming up next year, then just send us a note or put them in the feedback form or in the forum. And yeah, we look forward to planning lots of cool content and sessions in the new year. So yeah, help us plan that and give your input. We'd be really happy to have that.
Applause on that. Thank you, Tyler. It was good to see you, everyone. Have a nice week.
Thanks, everyone. Talk to you soon. Bye-bye.
Yeah.